So let's imagine Young were to shine light, the natural light he had available, on just two slits. So you might have one coming along, and I'll kind of represent the phase as some sort of variation in these lines like this, and then different part of the experiment, it might have a different amount of skips in the phase. But still, when the light goes through these 2 points, it's going to go somewhere, and it's going to be two waves, and they're still going to overlap. So you might say there should still be some interference, and there is. It's just the interference condition did depend on the phase. It depended on epsilon, epsilon 1 minus epsilon 2, and epsilon 1 minus epsilon 2 are changing a lot in this experiment. And they're changing with natural light about every 2 nanoseconds. So to give you an idea of what would happen, recall my crazy overlapped plane waves here. So here they are. Remember, you can kind of see where it's bright blue, bright red, bright blue, bright red is constructive, and where it's kind of dingy purple, it's destructive. So now I'm going to shake one of these really fast. And you can see what that basically does is it just washes out the interference pattern. If you have big skips in phase where it's bright and where it's dark, it just jumps around. And if it does it every 2 nanoseconds, then your interference pattern is lost. And this is why Young couldn't do this with just 2 slits. This is why Young's double slit is really Young's triple slit, because there's also something called spatial coherence. And just a simple definition would be the skips in phase are the same over a wavefront. And how much of a wavefront? So for natural light, it's about 0.1 millimeters, say. Not meters, millimeters. What this means is, here I drew these 2 waves really far apart. They would have different skips in phase. But if you have a wave going along, and it kind of goes a few, and then it skips, and then it does 2, and then skips to does 4, some phase front or wave like this, as I'm drawing it, you can imagine, what if you had 2 sources like that? Then those 2 would be in phase. So that's what the third slit is for. So if we have a slit like this, it accepts this plane wave. This size is really small, small enough that it's spatially coherent. And then the light that diffracts through this slit, which we draw as a round wavefront, which we can think of in terms of Haugen's wavelets. Later we'll know it's because of diffraction. We haven't done that in detail yet, but it'll come out with some skipping phase to make a spherical wave. But then, since we have spatial coherence, what makes it to the double slit, even though it's skipping in phase, it's skipping in phase the same way in each one of these double slits. So even though what's coming and going to some point that we're going to analyze skips in phase, it does it together. And then maybe it skips up here, it does it there also. And then eventually they get to the magic point P that you're always pursuing when you do Young's double slit. So anyway, coherence is the reason he had to use 3 slits. And like I said, coherence is very complicated. We're not going to do it in detail, but I'll bring it up several times as we go and talk about interference, places where it shows up experimentally.